We've seen that confidence intervals can be used to estimate a population parameter from a sample statistic. We built that up using sample means in the standard error of the mean, and we've also done that with proportions. There's another statistic which is very interesting, although it's a little counterintuitive, and that statistic is the difference between two population means. Relax a little bit and think generally in terms of what a confidence interval is and what a statistic is, and you'll be able to answer some very interesting research questions around the difference in population means. Imagine we want to measure the mean blood pressure between one group, drug A, and another group, drug B. How would you do that? Take a bunch of people, give them drug A, take a bunch of people, give them drug B, calculate the means, and then look at the difference between those two means. The statistic is the difference between those two means. Does the average male have a higher lead than the average female? Two populations, male, female. Measure the mean lead concentration in their blood. Which one is higher? Calculate the difference between them. What number will you get for that difference? Well, I don't know. I have to take the samples first. I have to take a sample of males, a sample of females, calculate the difference. If you don't know what that number is going to be until you actually calculate it by taking a random sample, guess what that statistic is? It's a random number. And if it's a random statistic, that means it has random variability around it. And that means you can calculate the standard error for the difference in the population means. It's not very obvious, but this is really cool. It builds exactly off the stuff that we've done. Let's say you have a group of turtles. This is a reference to an old TV show called The Simpsons. We have turtles in this town, turtles in this town. Calculate the mean of some continuous variable. Okay, this is what I got from my sample. What does it say about the population of all turtles in those towns? We got to put a confidence interval around it. A confidence interval for the difference in population means. This opens up a world of interesting research questions. This slide, students either love or hate this slide. I like it because it walks through the idea that the difference between two means is a statistic and it has its own sampling distribution. So let's think for a second. Let's think about those male infants in Quito, Ecuador. Let's say here they are. Here's the distribution of the blood lead levels in boys. Individuals, right? You can describe those individuals by the population mean, the mu. You can describe the spread of those individuals with the population standard deviation, the sigma. And then let's say there's a population of infant girls, two different populations. Do boys and girls have different lead levels? Well, I don't know. Let's take a sample and find out. So I could take a sample of a given size. I could take a sample of a given size. The distribution of the mean lead levels, we already know. We worked through this a bunch. You saw some applets with a distribution of bars, and then little samples fell down, and then there was a distribution. That's called the sampling distribution of X bar. We saw that. And that gets described with the SEM, the standard error of the mean. And if you sat around and you spent the rest of your life taking samples and taking blood from little boys in Quito, Ecuador, you could calculate the mean each time and it would look something like this. And you could do the same thing and you could calculate the mean of the girls and it would look something like this. Those are the sampling distributions of the mean. Now, the new part on this slide is, what if you took a sample of boys and you took a sample of girls and then you calculated the difference between those two samples? What would you get? I don't know. You got to take a sample and get it. Why would you get a different number every time you did it? It's random. So the sampling distribution of one mean minus the other mean, the difference in means, is a random variable. And if it's a random variable, that sampling distribution can be described with a standard error. What would you most likely get? What would be the most likely value to get? Well, it would be whatever is that true difference between boys and girls. Let's say boys are higher. The truth is boys are 5 units higher. Well, you take a sample, most likely you're going to get something, a difference of 5. But you won't get that every time because a sampling variability, you get a different number. So this curve shows the sampling distribution for the difference in two means. And again, this is weird, but it builds right off everything that we've done. So let's think about, how do you describe the spread of the sampling distribution for the differences in means? Well, you can look up the formula. If you Google it, you'll get something like this. We're going to make a confidence interval. When we did one mean, we saw that it was something like this. X bar plus or minus a multiplier, and then we saw sigma divided by the square root of n. Now, you can write this another way. You can take out that square root sign and put it here. These two things are equivalent to each other. I mean, we simplified it. We just said that's 1.96 times the SEM. Now, okay, we get that. We understand that. What if we want to go and generalize it to the difference between two population means? Well, what's our statistic now is the difference. We still do plus or minus. We still do the multiplier. And then the SEM now will look something like this. Now, the great thing is a computer will always do it for us. But if you take a look at what this is, we have the sample of boys and their spread, the sample of girls and their spread, the sample size of the boys and the sample size of the girls. It's the exact same thing. This and this are exactly the same. It's a new statistic, though, which opens up a world of interesting research questions. So blur your eyes a little bit. All confidence intervals are pretty much the same general thing. You have your point estimate or your statistic from your sample. And then you add a fudge factor or some measure of uncertainty, which is some sort of multiplier or some critical value. It might be 1.96 if you have a normal distribution. It might be the t statistic if you're using a t distribution. And then you multiply it by some sort of standard error. In English, the standard error is just how much does this stuff bounce around by chance alone. Now, when we do the differences in population means, we can calculate this pooled standard deviation because the boys and the girls might have a different spread in the underlying population. And the way you do this is you take the standard deviation of the boys and the standard deviation of the girls, and you weight it based on the sample size. And then this will give you the pooled standard deviation. And you can use that to calculate the SEM. Sorry, the SE for the difference in the means, and then calculate your confidence interval. Now, when we write out these confidence intervals, we have to be very careful that we include some elements. And when you're first learning this, always double check that you have these. We're talking about continuous variables, so we have to be clear that we're saying the mean blood lead level, for example. Always indicate which direction you are talking about. Higher, lower, more, less. Directionality is so important. Think that your units have to be included. You might want to say the observed difference between the two groups. On the average, boys are 5 units higher than girls. And then our confidence interval is between this and this. So there's our bounds of the confidence interval. And then most of the time you're going to be dealing with 95% CIs, but there's nothing written in stone that that's always going to be the case. So for now, be explicit. We are 95% confident that on the average, boys are 5 units higher than girls, and our confidence level might be between 4 and 6. Or if we have a smaller sample, it might be between 3 and 7. So make sure you have these elements in here when you summarize your confidence interval for a difference in two population means.